Hey everyone, welcome. This is a intro video to getting started in Python. This is Eddie from the Sports Analytics Club. For those who may know, or for those who may not know, um, what this is designed for you is just to help you get started, so that way in the future you don't have to ask a lot of questions in person or feel nervous to ask. This is kind of a reference video. So it's going to be kind of a four-part series, I believe. First one's just going to talk about how to install Python, talk about some things that you can integrate with it, and then just going over the very basics. So, what you want to do first is install Python itself. You can load up python.org and it should take you straight to here. When you download, you want to hover over the download, and then I'm using a MacBook, so it's going to be a Mac OS. If you're Windows, Linux, whatever you have, whatever operating system you have, you just click the download link and then just follow the prompts from there. Next thing you want to install, specifically if you're going to data science, is a thing called Anaconda, if I can spell. And should look something like this, like a green snake looking thing. And you're going to select download Anaconda distribution. We're not going to register. You'll just hit skip registration. And for Anaconda installers, you can download. Again, I'm on Mac OS, so it's going to recommend downloading for a Mac. And if you have a Mac, majority of you all most likely have a one with an M chip, so you would download Apple Silicon. If you have like an old laptop, like pre like 2018 or something like that, you just download for Intel because you more likely have like a I chip or Intel chip. But most likely you're going to have Apple Silicon. The last thing I'll mention is this is optional. You can download an IDE or an integrated development environment. One that I recommend is Visual Studio Code. And this is an IDE that you can use like what I like about Visual Studio Code is it's pretty easily integrated with whatever uh, development environment you're trying to use. It's also good at linking to your GitHub, so you don't have to worry too much about Git commands, even though Git commands are important. Um, I also like the lightweight feel of it too. It doesn't feel like it runs slow as some other IDEs do, but that's just my preference. But once when you have Anaconda and Python installed with the optional IDE, the first thing I'm going to go over is just how to open up a Jupyter notebook because as data scientists, that's probably what you'll most likely deal with. There are different ways to getting uh, your notebook to open up. If you, for me, it's on the launch pad and you can open up Anaconda Navigator. If you're on Windows, you can still look through your file directory. So either in Finder or the folder icon in Windows. And you should be able to launch the Anaconda Navigator just by looking at your downloads. So I have Anaconda Navigator opened up. What we want to do is hit launch for Jupyter Notebook. That'll open it up in a new tab. That's one way you can get there. If you want to be a little creative about it, you can do it in the terminal. Uh, for me, I just do Jupyter and then you can press tab to fill it. How I have it set up with a hash, but some of you all may not have the hash, so I would just recommend hitting tab, hitting like a space, and then try typing out notebook and see if that works, or underscore, whatever should work. If not, easiest case is just opening up in the launch pad. So I'm gonna run that real quick and then reshare my screen on how that will look. Bam, should see it. So we got home page here. I'm going to go into the coding lectures, which is I have synced to GitHub. We're going to create a new folder, or you don't have to create a new folder. I am. And I'm just going to call this Intro to Python. I'm going to open up this folder, and then we're going to create a new Python kernel. I guess we can call this introduction. So the basic layout of Jupyter Notebooks is Python's an interpreted language, and how Jupyter Notebook works is it's ran by each cell. So each cell is kind of like its own interpreter. And the best part about it is it's all saved. So it's saved in this thing called the kernel. Um, Unlike things like VS Code, like if you're running .py files, for instance, it's all got to be ran at once. What Jupyter Notebook does is it saves it in .ipynb, where you run these cell-based commands. So the overall layout of this is you've got your save button. You can also do Command or Control S to save. You hit the plus to insert multiple cells. To delete, I believe the basic configuration is double tapping the D key. Um, to run, actually, I'll get to run in a minute. What else can I talk about on here? You have the code, so you can convert to code or Markdown. If you don't know what Markdown is, that's all right. It's always good to learn Markdown to help organize yourself. The hashtag, so this is like a heading or a title, and we can call this heading, say, data types. And then to run it, you press Shift Return or Shift Enter, and it should run the cell and move to the next cell. If you want to just run the cell in place, you do Command or Control Enter. I usually like doing Shift Enter just because I like naturally moving on to the next cell. All right. So let's go ahead and just introduce you to some Python syntax. So I'm going to go over some basic data types. So I believe, if I recall, there's your strings, integers, your floats, booleans. Those are kind of the most primitive ones that you deal with. So a string is anything in quotations. You can do single or double quotes. Hello world. Um, you could do integers, which are any whole number. It can be negative as well. Floats, which is an integer but with a decimal point. Again, can be positive or negative. And then you have Booleans. So in Python case, it's capital. So it can be true, false. Some other data types that are a little more complicated are things like dictionaries, tuples, lists, and sets. Those are the main ones that you kind of need to know. So you've got a dictionary, which is with curly braces, and you have your key value pair, tuples, which are just parentheses. I'll get into like the importance of each in a minute. So I'm just going to kind of introduce you to it. Lists, which is just in brackets. You'll deal more with lists and dictionaries more times than not. And then sets, which is again, it's curly braces like dictionaries, except you're using commas. So this is what a dictionary would look like with key value pairs separated by a colon, and then like a comma, key 2, value 2. So this is what a dictionary would look like. A set has curly braces as well, except it's like a list, essentially. All right. I'm going to take a moment to explain why each of these are important. So dictionaries, I've kind of already touched upon that. It's key value pairs. It's the most common data structure you're going to see. If you know Java going into this, it's essentially a hash map of the key value pairs, and you see that a lot with APIs, JSON structure. So dictionaries are going to be the most common thing that you see in data science, from my experience in that case. Next thing is tuples. So tuples are like a list. So you can save something like this. This brings me to my next point. So we can save this into a variable. So my tuple. and then we can output it here, like so. The good part about what makes tuples awesome is it's immutable, so you can't really manipulate it. So it's not really gonna take up much memory. So I'm gonna show an example of why it is, or like to prove my point that it doesn't really take up as much memory as compared to like a list that is mutable. So from here I have from sys import the get size of. Don't really need, doesn't really matter, or you don't need to know what this means. All I'm doing is I'm importing a function from the sys library. And when I run this and output it, 72. And what this 72 is, it's 72 bytes. So how your system saves these variables are it's in byte code. And the lower the bytes, the lower amount of memory allocated to them. The idea, like if you're running efficient programs, the idea is to have lower bytes being used. But as a beginner, you don't really need to be too concerned about that. So let's compare that to, say, a list of the same length. And I'll just keep this things the same. I could also do something like this. Convert the tuple into a list. Two different ways you can do it. So if we do my list again, it's going to output this instead in bracket form. We do get size of my list. You see it converted more bytes because lists are mutable, which means you can add things to it. So I can do like my list dot append uh, one in string, and if I output the list, it'll append one at the end. Keep in mind too, in Python, if you're using the basic data types here, you can do just about like, or I guess in these structured data types, you can use just about any of the primitive ones inside of it. So for instance, you can add integers in a string inside a tuple. Same thing with a list or a dictionary, compared to like Java where you have to have the same type. So that's a cool part about Python. I wonder, yeah, it's the same because it's the same size. Okay, makes sense. Just wanted to try something out if it was all in the same data type. But I digress. Um, those are essentially the main things you need to know for the data types. And I've introduced you to variables, so it's the same thing that you would do in, say, like Java for assignment. You hit the equals to assign it to something, and it's stored in memory. Now, what's cool too is it's saved in memory throughout each cell, so you don't have to reassign it and rerun it. However, if you do want to reset everything, you'd hit kernel, restart, and then you just hit restart. So if I try to output, say, my list here, it's going to run a thing called name error, and it says my list is not defined. That just means there has been a no assignment, aka an equal sign, to a list. And I'm just going to delete all this. Um, I guess another thing I could talk a quick bit about are like for loops. So I think in Java it's like for I of I is less than something, and then it's like I plus plus. Can't really remember. But in Python it's for I in. The in is like a keyword here. And then in range 10, print I. And if you'll notice, Python is like Java. It starts with zero-based indexing, meaning it starts from zero and then ends at n minus one. So in this case, 10 is the n. So it's going to go from zero to 10 minus one, which is nine. That's how for loops work. You can also do if statements. So, if I is 4, print hello. You see on the fourth element, it's going to print hello. And you can see 4 is also printed out here. So if I didn't want that, I would hit else. So if else statements, if if it's true, do this. If not, do the other things. That's why at 4 is not outputted here now because I put it under the else. So it went away. Hooray. Okay, let's do something a little more fun. I'm gonna go over functions. How do functions work in Python? Again, in Java, it's probably like public, the type, and then the function name, and then your parameters in there, and then you gotta do the beautiful curly brackets. Python, it's different because it's an indentation language. You don't have to use curly braces. So Python understands that this is indented, which means it's like a curly bracket, or it needs to read this line. So I'm gonna do like a add function, num1, num2, and we could return num1 plus num2. We'll call add, say 1 and 3, and we get 4. That's literally it with functions. That's all you really need to know. You don't really need to specify the type. You can if you want. You can specify the typing of it just to make it cleaner. So like you expect this to take an integer, expect this one to be an integer, and then the return type will be an integer as well. This is what return is in Python. So you can do it like that to make it look cleaner. You don't have to though. It's again in the interpreter, it's going to understand that what's taken in is an int. I don't think there's much else that I could think of. Hmm. For functions, I'll get right into object oriented because that kind of implements functions to it as well. So we've got object oriented programming. You're not going to see this too much in data science just because you're more so data manipulation and analysis of it. I'll get to that in the next video. This is more so a brief introduction to how it works. So if you took this is also kind of geared towards people who are moving from Java to this. So I know in the intro to the Java classes, you learned something called object oriented. So I wanted to show how that looks. In Python, typically object oriented, if you're in data science, is either going to be used for like if you're building a scraping function and you're trying to extract data from the web from multiple sources, but the functionality is the same, so you can inherit from it. Um, Packages, just how packages are organized, because there's like a bajillion packages in Python. Those are usually built with object-oriented design. So I'm going to go over how that looks. So I'm going to define a class. We'll call it dog. You don't have to put this part, like you can call the class literally like this. But I'll just show what it inherits from. It's going to inherit from object. Ooh, trick question there. For those who know Java, obviously it's the same thing. If we want to initialize the dog, though, here's where it gets a little different. In Python, you got to define an init function, which initializes the dog, what it takes in. So we'll do self, and then what does it take in? We can specify a breed, an age, and pause. We can say, um, has a long tail. And then you just do self dot breed equals breed, self dot age equals age, self dot in pause equals pause. Oops. In then self dot, if I can spell, dot as tail equals has long tail. And that's just what initializes the dog object. So if I run it, we can call the dog. So instead of doing like dog equals new dog, you can literally just do dog equals dog. And we'll say the breed, golden retriever. I'll say, hopefully I spelled that right. Age will be 10, pause will be 4, has long tail, true. We output dog, it's a dog type. Now, say I want to get the age of this dog. Well, there's getters and setters in Python as well. So we can define get age. We'll do self. Keep in mind when you're defining these functions from a class, you want to have the self there because it's referencing itself. So it's all going to tie into uh, these selves that you initialize it to. And yeah, so this is going to have return type. So we're going to return the self dot age. And then, so we want to set the age, self, and then new age. You return self, or no, we're not returning anything here. Self dot age equals new age. And this is going to have no return type because all we're doing is setting it. Bam. We'll just rerun this. Dot get age 10. So you want to set the age now. Dog dot set age. We're going to set it to 12. And then we're just going to get the age again. Bam. So we've set it to 12. The last thing I'm going to show for object-oriented is inheritance. So the idea with inheritance is you want to start, it's like a hierarchy system. So at the very top, you've got the most generic feature, and then it gets specific as you trickle down the ladder. So what is something that's more general than a dog? Well, if you said animal, I would agree with you. So let's say we do animal, and again, this would inherit from an object. And for the dog, it's going to inherit from animal. We're going to define the init here. And let's just say uh, something that's in common with the animal and the dog would be an age. We'll just do self.age equals age. And to show you that I'm not crazy, we're going to move these functions, Control X and then Control V, up to here. Because this dog can inherit things from animal plus whatever the dog can do. Because that's the general idea of inheritance. So that way you can add more stuff as you get more specific. To truly inherit from this, you got to do a super, the super keyword for it. And we're going to do dot init to initialize self and then age like so. So we don't really need this here. And then just for kickers, I'll just do the a different thing. So maybe get read, and then we'll do set read. And I forgot the self here. So, and keep in mind, we also need a colon too to finish out the function. All right. Takes two positional arguments, but three were given. Beautiful. Okay. Um, what did I do wrong here? Super dot init age. That wouldn't be right. Yeah. When you initialize it. Oh, because I don't need the self there. Whoops. Um, don't get confused by that. You don't need the self. When you initialize from the inheritance, you just need the variable that you're taking in. So in this instance, it's going to be age. Sorry about that. Uh, didn't mean to confuse there. But that kind of defeats the purpose of what we're trying to do here. So we have our dog. I'll rerun this. And we can still use the get age function. Even though it's not in the dog class anymore, it's been inherited from the animal class. So if I run it, it's going to spit out 10 again. And we can still set it to 12. And we can even get their breed. Bam. Like so. So that's essentially all I wanted to go over, the very, very general basics of Python. Uh, the next lecture is going to be a little more intense. It's going to be learning about how to scrape off of a website. So just be patient, just follow along, and you should be fine. Again, if you want to save it, you can do Command S if you're following along with me. But yeah, if you have any questions, feel free to reach out. You can comment on this video if needed, or if you're in the Sports Analytics Club, you can just reach out to me on Discord. But yeah, hope you enjoy the rest of your day.